let's continue on with the same population problem and do number 26. So I have my, this is my equation right there of the linear model for the population between 1950 and 1960. So I'm going to kind of just repaste that right down here if I can. And I think I can. And what it says is that in 1970, the population was 205, 052, 174. Is the model for the U.S. population from 1950 to 1960, which is this, appropriate for the 1970 population? And I'm supposed to explain that. Well, let's go back up to what we're doing. Here's our graph. We had through 1950 and 1960. So here, t was 0. Here, t was 10. If I go out 61, 2, 3, 4, 5, 7, 8, 9, 6, 7, 8, 9, 1970, now my t is equal to 20. Well, then it should be easy to test. I'm just going to take my formula right here, and I'm going to plug in 20 for t. So I managed to call up my calculator here. So I have 2,839,974 times 20 plus 152,271,417. Enter. That comes out to be, so t, let's do this. This instead of y is population as a function of time. So population evaluated for 20 years is equal to 209,070,897. Is that right? Yeah. Comma there. Too many digits. Well, they aren't the same. These two are not the same. But if I remember in the very beginning of the description, they told me that a 5% variation is acceptable. Well, the difference between 209,070,897 and 205,052,174 is 404,018,723. So I would take that number and divide it by my 205,052,174, and I get 1%, a little bit, 1.9%, so 2. So yes, this model is appropriate for the population to 1970. Let's follow the same logic and find an answer to problem number 27, and it's asking me, what about for 1990? So it's going to be the same process here. 1990, the population was 249,464,396. Well, 1990 is t equals 40. So that's 40 years away from 1950. So I'm going to go P40. Let's just plug it in here. I'm going to go up to this equation that I had right here, or that number, and I'm going to enter. So it just replaces it right down at the bottom. But I'm going to change 20 to 40. And I get that equals 265870377. Uh-oh, I made a mistake. 265 265870377. There's my commas in the right place. So again, I need to look at the difference between these two numbers. This is the actual, and this is the projected according to our model. So if that was my projected, then I'm going to subtract 249464396, and then I'm going to divide it by 265870. Whoops. Put that. I'm going to divide it by 265870377. Well, I find out that I am 6% off, 6.1% off. And that is beyond my 5% tolerance.